Nell's and others' work show that growth mindset interventions in the area of math has increased motivation and excitement about challenge. The interventions have also helped to close the gender achievement gap. We hope by applying similar interventions to CS, we will be able to achieve those same results: increased motivation, excitement about challenge, and a decrease in the gender achievement gap.
So there are two main research questions that we hope to address. The first one, how can we develop an interface that supports students developing a growth mindset by providing useful feedback embedded within a student's code editing interface? The second question, will rewarding the growth mindset in computer science increase women's interest in computer science? In order to solve these research questions, we need to tackle two sub-challenges. The first one is the tech research question. How can we automatically detect user behaviors that signify effortful actions that are conducive to developing a growth mindset in introductory programming? And secondly, our design question, how can we use detected signals of effortful actions to then provide feedback within the user interface that reward effective actions as in BrainPoints?
So when doing need finding, we conducted 6 user interviews to help us gain better understanding of our target users and their mindset before and after learning coding. We developed a journey map, shown here, and a storyboard to help empathize with the users and understand their process.
Next,
Here's the storyboard.
we sent out to try to build some tech for a project. We additionally wanted to find a keylogger that we could download and use so that we could collect keystrokes from our users, but after looking through the possible options, we didn't find anything that really suited our needs. So instead, we went to Atom to try to build a package. We built a package called Keystrokes that allows users to turn the package on and then collect keystrokes into an Excel file as shown here. As you can see, there's a view controller at the bottom that shows what keys are being pressed, and at the same time there's a CSV file on the desktop, and in the CSV file it records the timestamps from when the user pressed the button and the keys that the user is pressing.
So at the end of the quarter, once we got our tech working, we decided to design our user study. The duration of our study is going to be the first 2 weeks of April, and we are going to be, the participants in the study will be Northwestern College students in Professor Sarah Sood's class, The Fundamentals of Programming 1.5. We chose these students because they have minimal programming experience. And within the study, we are going to have the students complete the following high-level tasks. 1, we want them to complete a survey at the beginning that will indicate whether or not they have a fixed or growth mindset. From the survey, we are going to select students with conclusive growth and fixed mindset results from the survey. Next, the students that we select, we will have them download our Keystrokes Atom package that we created. Using this package, the students will complete their first 2 homework assignments in the normal program environment that the rest of the class will be completing their homework in, which will be Atom. And then at the end of each homework assignment, we're going to have them email us their keystrokes.csv file that our Atom package created for them. Additionally, during these 2 weeks, we are going to observe a select group of students that showed extreme growth and fixed mindsets for an hour each in a location of their choosing in order to try to develop heuristics and be able to visualize what the growth and fixed mindset may look like. And at the very end of the study, we will have the students complete one last survey that will again indicate whether or not they have the growth or fixed mindset and see if their results changed over the course of these 2 weeks.
So we did some user testing to try to determine what the interface should look like and kind of answer our research question that is related to the interface. And through user testing, we kind of we set on this prototype. As you can see, there is an ever-increasing score at the top for how much the user has exhibited the growth mindset, and this is similar to reputation on Stack Overflow, which is another platform that coders use. We are playing around with the idea of the background color changing in accordance to whether or not the user is exhibiting the growth mindset. And in this storyboard, you can actually see how the color changes based off of how the user is doing. And then finally, at the bottom here, there's commentary to encourage the growth mindset and kind of get the user back on track if they fall into a fixed mindset. We hope to use this data. We also hope to use the data. We hope in future findings will include developing heuristics from user behavior that will allow us to detect the growth mindset.
Some of the limitations that we're currently facing are that right now our package only collects keystrokes, but we also want to be able to collect mousing data so that we know where and when somebody is typing in a text file. We also hope to be able to analyze Google searches so we can see what people are looking up while they're coding, since many people use Google while they're coding. Finally, we want to be able to analyze our collected data, either using machine learning or heuristics or a combination of both. In our next steps, we plan to conduct our study as we talked about in the first 2 weeks of April. Using the data from the study, we want to develop heuristics that we can look for, such as features in people's code, and determine whether or not that relates to the growth or the fixed mindset. After that, we want to run classifiers on those data based on the features that we decided we wanted to look for. Finally, we hope to be able to combine our results from the heuristics and also from machine learning algorithms to be able to detect the growth mindset automatically.